Okay, real quick kitchen experiment. I grab a jar of coconut oil and a glass of water. I put both on my counter. 10 minutes later, the water is still totally liquid, but the coconut oil looks like it's turning into white butter. What gives? Here's the short answer. Coconut oil solidifies at a warmer temperature than water. In other words, it freezes sooner. Coconut oil hits solid around 24 to 26 degrees Celsius, about 75 to 79 Fahrenheit. Water doesn't freeze until 0 Celsius, 32 Fahrenheit. So in a normal room, coconut oil can go solid while water stays liquid. Now, the why. It all comes down to molecular shape and the kind of glue holding those molecules together. Water first. Each water molecule is like a little boomerang, bent shape, with a positive side and a negative side. That polarity lets water form strong friendships called hydrogen bonds. Picture tiny magnets snapping together. Those bonds are beefy. To lock water into ice, or to break it back into liquid, you're battling those strong hydrogen bonds. That's why water needs to get all the way down to 0 Celsius before it freezes. Coconut oil is different. It's mostly saturated fats. Long, straight hydrocarbon chains. Think uncooked spaghetti laid side by side. Because the chains are straight, they can pack tightly, like a neat stack of pasta. The forces holding them together are weaker than water's hydrogen bonds. They're called van der Waals forces. Not magnets, more like gentle Velcro when lots of strands are touching. Here's the twist. Even though each van der Waals force is weaker than a hydrogen bond, those long straight chains make a ton of contact with each other, so the total stickiness adds up. And because it doesn't take much cooling for those chains to line up and cuddle into a solid coconut oil firms up at a higher temperature. So why does saturated matter? Saturated means those chains have no kinks, no double bond bends. Straight chains pack better. Better packing, more surface contact, more van der Waals grip. If you swap in unsaturated oils, like olive oil, with kinked chains, they don't stack nicely, and they stay liquid at room temp. Let's translate this to daily life. If your kitchen is cool, say 72 to 75 Fahrenheit, your coconut oil might look cloudy or fully solid. Warm the jar with your hands, or a little warm water bath, and it melts back clear and liquid. Nothing's wrong with it, you just crossed its melting point. Recap in 10 seconds. Water, bent. Polar molecules, strong hydrogen bonds. Freezes at 0 C. Coconut oil, straight saturated chains. Lots of close packing. Van der Waals forces add up. Solid around 24 to 26 C. Next time your coconut oil turns solid on the counter, you're not seeing a fail, you're seeing chemistry in action.